Hello everyone, myself Sowmya, Assistant Professor in CSE AIML Department, MLR Institute of Technology. In this video, we are going to discuss about Bitcoin blockchain. Coming to the overview of this presentation covers history of Bitcoin blockchain, need for Bitcoin, the common terminologies which we are using in Bitcoin technology and Bitcoin mining. So coming to the history of Bitcoin blockchain. So when this Bitcoin has evolved, how it is evolved, right? The history of blockchain we are going to discuss. So on 18th August 2008, on the exact date, a website domain in the name of bitcoin.org was registered. So the first website on Bitcoin was bitcoin.org was registered in the year 2008. The date is 18th August. In the same year, 31st October, Satoshi Nakamoto or Satoshi Naga, he is a software developer in Japan. So he published a white paper on Bitcoin, published a white paper in the sense in his portal or in his blog, he presented or he proposed a white paper on the concept of Bitcoin. And he introduced Bitcoin to the world on 3rd January 2009. So officially he has introduced about the Bitcoin in the year 2009. He coded a special software to create Bitcoin. This software is based on a blockchain technology. As we know, Bitcoin is a what we call cryptocurrency. Bitcoin is a cryptocurrency. So to create this cryptocurrency, he used one software. So that software is using the concept of blockchain technology. So as we know, blockchain technology or this Bitcoin is based on public blockchain. So anyone in the world can use this technology. So anybody in the world can use this software. People who create Bitcoins are called miners. So who create Bitcoins are called miners in the sense how they can create the Bitcoins by validating the blocks in the blockchain. If I validate a block in the blockchain, then I will get the Bitcoins in terms of incentivization. So Bitcoin touched its peak value in the 2017, which is $19,498 US. So initial Bitcoin price was it's less than one US dollar, but in the year 2017 it has reached to its peak value, which is $19,498 US. So when the Bitcoin was created, the value of one Bitcoin was lesser than 1 USD. So just now we discussed about it. And this is the symbol of a Bitcoin. So it is a digital currency actually. We don't have any physical form of Bitcoin. We have only what we call virtual. Bitcoin is secured currency and can be used very quickly. So of course it is secured. Why? Because we are maintaining only in terms of digital wallet. So nobody controls this currency and hacking the Bitcoin network is very difficult. So here, for every digital wallet, there will be some public key as well as private. So hacking of these two keys is very important. Very impossible. It is impossible to hack this private key. So which is actually a 64-bit or 128-bit based on our usage. And there are no forms of governments to regulate the Bitcoin currency. So we know if you are using if you are staying in India, we are using rupees. If you are staying in US, you are using dollars. So for that, they have some regulations based on the government. We have some regulations, but as it is a cryptocurrency, we don't have any regulations like that. So why we need this Bitcoin? As we know, the dollar is the currency of US, pound is the currency of Britain, rupee is the currency of India. So now I want to exchange the money. So if I want to convert US dollars into rupees, there is some process, right? So they will deduct some amount also for that. Why? Because so every country is spending so much of amount for this physical currency. Right. So to convert that from one way to other way, we have some regulations. So I need to follow all those rules. They will deduct some amount also. But for this, we don't have any physical form of currency for this Bitcoin, right? So we have only a digital currency concept here. So a commission is to be given to the current exchange for this conversion. So if I want to convert from this US dollars to rupees or pounds to rupees. So we have some regulations for that. We have a lengthy process for that. But On the other hand, a cryptocurrency is a direct P2P system without intermediaries. So if I want to send from US to India directly, I can send without any of these things. So why? Because here they are following digital currency. Here also we are following the same process, digital currency. Directly we can transfer it. So there is no need to spend millions to create bitcoins. Also, since only 21 million bitcoins can be built across the world, it will not lead to any inflation. So here we have limited amount of bitcoins already. They have what we call initiated. So we have only 21 millions of bitcoins already introduced. So there is no new productivity for this. So they are not going to produce any new bitcoins here. We have a limited stock of this bitcoins. So the growth of Bitcoin is depicted in this diagram. So in the 2010, the Bitcoin value is $0.09, whereas it is increased. And if you observe in 2017, it has reached to its peak value, which is $19,498 US. And after that, in 2017, we got an issue. We have an attack called Diego attack. So because of that Diego attack, it has decreased its value from 19,000 to 13,412, and later it has decreased to 8,221 in the year 2019. So coming to the common terminologies which we are using in terms of Bitcoin network. The first one is mining. So what do you mean by mining? Creation of Bitcoin blocks are called mining. So mining is a mechanism whereby nodes called miners in the Bitcoin world validate the new transactions and add them to the blockchain ledger. So here for performing the mining, as we know, blockchain is a decentralized network. There is no central authority to validate any transaction. So how can we check whether a transaction is valid or not? Whether I can add this transaction to the network or not? So how we are validating that? Using a process called consensus mechanism. So in consensus mechanism, what a node will do? A node will solve one mathematical puzzle. It depends on the consensus mechanism which we are using. For example, if I am using a POW, proof of work consensus mechanism, then the node is going to solve one mathematical puzzle. If it is solving the puzzle successfully, then that particular node is going to validate the transaction. So whatever the new transaction you are adding, that will be validated by that particular block. So this process, if this process is successful, then that node is going to be incentivized with some bitcoins, right? So this process is called as mining, and that person or that node, particular node, is called as miner. So using this mining process, a person or a node can mine the bitcoins. And block frequency. So Bitcoin transactions are being registered into blockchain once in 10 minutes. So to create a block, how much time it is required? So that is called block frequency here. So in 10 minutes time, we can create one block. So one block will contain different types of transaction, number of transactions here. So coming to the industrial mining. When all nodes are uniform size and power, every node gets equal opportunity. For example, I'm using some system with CPU and some others are using a system with a GPU. So of course, this person's system is having high computational power. Then his work may become simple or easy, or he can finish the work easily with less time when compared to this system, right? But if all the persons are having the same power or same energy, then we can, the work will become easy, or the comparison will become easy. So, for rewarding also, for incentivization also, this process will be good. So, for that purpose, we have some nodes which do industrialized mining and connect to a massive set of computers, consume enormous power and use complicated software. So, industrial mining, in the sense, it's just like a cloud. So we have some architecture, or we have some resources. By connecting to that, we are taking all these resources. Of course, my system is not capable of having a GPU or any what we call the higher power. Then what we are doing, I'm taking the use of this cloud, right? In the cloud, we have all these resources. By using those resources, we can do this process, mining process. So mining pool. To contract with the high time and energy consumption in transaction validation, some mining groups together and mining pools to combine their mining resources. Another case, one is industrial mining, that is fine. Another case, So these two persons combines together and they will share their what we call the resources what they have to solve the puzzle. If they win, they will get some amount, right, in terms of bitcoins for incentives. So they will share that amount. So these people will group together to share their mining power or the computational power. And halving policy. So if the transaction is validated by a node successfully, then that node will be incentivized. So that incentivization mechanism has a policy called halving policy. So nowadays a miner is getting 6.25 bitcoins if as a reward. If he is validating a block, then he is going to get 6.25 bitcoins as a incentive. From the year 2009 to 12, 50 bitcoins were given as reward. So initially they were giving 50 bitcoins as a reward, and the reward will be reduced to half for every 4 years. So after 2012, it has decreased to 25. After 4 years, it has decreased to 12.5. After 4 years, it has decreased to 6.25. So next it will be 3 point something. So like that, this will be repeated till 2140. So at 2140 year, it will become 0. So next terminology which we are using in the Bitcoin blockchain is a block. So we know blockchain is a collection of blocks. So a block has 3 necessary information. The first one is block header, hash of previous block header, Merkle root. So block header. So each block is having a unique address that can be generated using SHA-256 secure hashing algorithm, which is 256 bit, right? So this hash code you're calling as a block header. And whenever I create a next block, to create this header, it is also using the previous block header. So that is hash of previous block header. So to calculate this header, what it is doing, it is using the information which is available in this block plus the previous header information also. How the previous header information will be available in terms of hash value again. And next, Merkle root. Merkle root is nothing but, for example, you have so many transactions, right? You have so many transactions in a block. So the what we call, you will apply hash for each and every individual transaction, and you will combine all those hashes together to get a final value, and that final value you're calling as a Merkle root. So it is the fingerprint of all the transactions in the block. So each transaction is having some fingerprint in the sense a unique value that you're calling as a hash. So consider H1, H2, H3 and so on. If I have 10 transactions, I will be having H10. So H1 to H10. If I combine all these hashes H1 to H10, I will get a value, and that value you're calling as a Merkle root. And so in this block, it is having 3 different parts, that is block header, hash of previous block header, Merkle root. Coming to the next concept, next terminology is a orphaned block. So detached or orphaned blocks are valid blocks which are not part of the main chain. So these are not part of our blockchain. So how does detached or orphaned blocks are created? In the sense, they occur naturally when 2 different miners successfully mine at the same time. For example, we have 2 blocks for validation. So this block is validated at the time 10 AM exactly, and this is also validated at the time 10 AM exactly. Then automatically one block will be propagated and one block will be added to your blockchain, and another block will be called under detached block or orphaned block. So this is officially a block only, but that we are not going to add into your blockchain. So next is mempool or also called as memory pool. So transactions are first added to the memory pool attached to each node. So each node may propose some transactions. I want to propose some transactions. Some other person may propose some transaction. So what are the transactions I want to propose? What I will do, I will place all these transactions in the mempool. Then whenever, if I want to raise the transaction will be raised and that will be validated. And after validation, those transactions will be added to your node. So that's a process. And block propagation. So when the block will be propagated to all other nodes, if it is valid. So if it is valid, if the transaction is validated by a node, then that will be propagated to all other nodes. So while propagating, each and every node should check whether the transaction is valid or not, whether the nonce is valid or not, and whether each transaction in the block is valid or not. So before propagating the transaction, we should check all these three things. Next is SegWit, segregated witness. The size of the signature and public key is so large within transaction that it occupies more than 60% of the overall size of the transaction. So each transaction can be identified using some value. So what is that? Signature and public key. For example, I have a node. In this node, consider we have 3 transactions. So each transaction is identified using some signature plus public key. So this transaction is also having signature plus public key. Signature, public key. So the signature and public key will occupy 60% of the space. Then where can I store the remaining transactions or the remaining values, right? So it is occupying the more space. That's why what we are doing, we are removing the signature part and public part, and we are maintaining that part as separately. So this segregation of the signature from the block is called segregated witness, which is also called as SegWit. So you are separating that signature and public key part from the transaction, and you are maintaining it separately. So that process is called as SegWit. So because of this, we can add more transactions into the block. So it is removing, right? We are removing that signature part so that the place will be more. You can add more transactions to that block. And next is nonce. So nonce is a number that can be used just once in a cryptographic communication. We know all the transactions or all the nodes, you are giving some unique value that you're calling as hash. So using hashing function or SHA function, you're giving some hash code for each and every transaction and for each and every block also. Along with that, we are also providing more uniqueness for your block or transaction using a number called nonce. So nonce is a random number which is used only once in the cryptographic communication. And what's the use of this nonce? It will provide more uniqueness for your block or transaction. So next topic is Bitcoin mining. So we know mining is nothing but if I validate a transaction, I'll get some incentives. So through that mining, I can get the Bitcoin. So this process is called as Bitcoin mining. So creation of Bitcoin blocks is called mining. So mining is a mechanism whereby nodes called miners in the Bitcoin world validate the new transactions and add them to the blockchain ledger. So if I am able or if I am successfully validating a transaction, after validation, obviously the transaction will be added to the blockchain ledger. So after this process, some incentives or some bitcoins will be given to the miners, and that process is called as Bitcoin mining. So we have 2 types of minings here. One is software mining, hardware mining. So generally software mining will be used by what we call big corporate people, whereas hardware mining will be used by the individual persons. Again, the software mining is divided into 2 types. One is pool mining and cloud mining. So pool mining, already we have seen that pool, right? Pool in terms of storage. But here it is different. It is done by the network of people from different places through a computer network. They share the value of Bitcoin at a ratio that is predefined and agreed upon. So I already told you that to validate a block, if I'm using proof of work, I need a system with more energy, more power. So it should be like what we call GPU or more than that, right? If we have that system, that type of system with more capabilities, then only you can validate a transaction. So if we are not having that much capacity of systems, then what we are doing, the multiple persons are combining their power, like the CPU power, whatever it may be. So this we are calling as a pool. So all these persons will combinedly work together to solve the puzzle to validate the transaction. After validation, they're going to get some incentives, and again this incentives will be shared by among these people. So this is nothing but pool mining. And next is cloud mining. So cloud mining, in the sense, if I don't have the capacity of systems, then what I will do, I will depend on the cloud. So this cloud will provide some resources. So using these resources, I can mine the block and I can get the incentives. After getting the incentives, pay some incentive part to this cloud. As we are using the cloud, then I have to pay the amount for that. Coming to the hardware mining, we have 4 different types of hardware mining: CPU mining, GPU mining, FPGA mining, ASIC mining. So based on the system which you are using, whether your system is having only the CPU capacity, or whether your system is having GPU capacity, or whether your system is FPGA or ASIC system capacity, based on the system which you are using, the corresponding mining will be used. So to use this hardware mining, we need to install a specific software. So based on whether if it is a CPU mining, a separate software will be there. If it is a GPU mining, separate software will be there. So like that, whatever the mining capacity or whatever the system capacity you have, based on that capacity, the corresponding mining technology will be used. But whatever the mining technology you are using, but you have to use one specific software to use this hardware mining. So that is about this video. In this video, we have discussed about history of Bitcoin blockchain, what's the need of Bitcoin blockchain, and the common terminologies which we are using in terms of Bitcoin technology, and Bitcoin mining, different types of Bitcoin mining we have discussed. Thank you.